Pininfarina has been designing the future for 90 years. The future of people, their dreams and desires. Design drives imagination beyond limits and technique. Design enables us to create emotions, meaning and impact. Enriching and enchanting how people move, play, learn and connect. We combine an innate Italian sense of beauty, balancing it with technological and business innovation, but also ethics. Design is more than an approach or a set of skills and tools. It is a mindset to interpret the world and to decide how to behave collectively to craft material and immaterial experiences, now and into the future. A future that we at Pininfarina will continue to imagine, design and build.
Ladies and gentlemen, thank you for being with us today to celebrate an important step in the history of Pininfarina. 50 years of excellence in aerodynamic and aeroacoustic research. In 1972, exactly 50 years ago, after a study conducted jointly with the Politecnico di Torino, Pininfarina became a leader in this sector when it inaugurated this building. It was Italy's first wind tunnel designed for the testing of full-scale passenger cars, and at the time, one of only 7 in the world. Everybody knows that Pininfarina has always designed with an eye to a better future, a design house that has always had the vocation to become the benchmark for sustainable mobility, just as it has been a global benchmark for the style of cars for the last 92 years. Always investing in research and development programs to tackle problems as they emerge in the motor industry. Just to give you an example, Pininfarina designed its first electric car in 1978, underlining that it was on the cutting edge in an area that the motor industry has only begun to reassess recently. In every Pininfarina project, design and function always go hand in hand as a systematic approach to the market. Thanks to this approach to design, Pininfarina has left its signature on the evolution of the motorcar. The wind tunnel fits perfectly into this Pininfarina approach to innovation, and it's precisely in this spirit of constant search for innovation that we want to celebrate today. So to begin, I would immediately give the floor to Chairman of the Pininfarina Group, Mr. Paolo Pininfarina.
Good morning, ladies and gentlemen. I am particularly proud to be here and also touched, emotionally touched, because the project of aerodynamics and the wind tunnel has always been related and tied with the Pininfarina company and the Pininfarina family itself. Actually, we are talking about 50 years, that is 1972, so it is during the presidency of my father Sergio, but the company was established in 1930 by my grandfather Battista, and the aerodynamic vision, the aerodynamic intuition was already present in the 30s. So let us remember the Lancia Aprilia aerodynamica of 1936 and the aerodynamic inspiration. Really, aerodynamics was, let's say, the manifesto Pininfarina innovation towards the competition. And the Lancia Aerodynamica was outstanding and was inspired by nature, by the shapes of nature. Let us remember my grandfather sentence when he saw the road mountains moved by the wind, by the cold wind of the winter, the side walls of the ice that was shaped by the wind. And he said, I want to design my cars shaped by nature, shaped by the wind. So that was the really objective. And he continued after the war with the Cisitalia, which had a strong aerodynamic input, and also the Abarth records in the early 60s. Then in the late 60s, with the economical boom, it seems that the aerodynamics priority almost disappeared from design in that period, but came again very, very, very important in the early 70s. And then my father, Sergio, had the intuition and the vision to anticipate the future, creating this laboratory that was actually projected with the Politecnico di Torino, who I thank very much and is present also today, represented today, and was engineered and built from 1966 up to 1972 with the opening. So casually, but I don't know how much casually, there was the Kippur War in 1973 with the energy crisis and the problem of pollution and problem of energy saving. So actually, the companies, the clients, used to come to the wind tunnel to make a better design for energy saving. So my father was really a visionary because he was able to transform a problem in an opportunity and in a competitive advantage. And that was an outstanding move. And I like to think that aerodynamics and the wind tunnel have this business, this activity has always been consistent through the years, from the 70s and the 80s and the 90s, the collaborations in the racing and the collaboration with concept cars, with the CNR and other means of transportation. We will talk again later. And then I like to remember also my brother Andrea, who made a very important upgrading in the beginning of this century, transforming the wind tunnel in a center of research aerodynamic and aeroacoustic. That was about 15 years ago, but Silvio will explain better this. So I'm happy, I'm glad, I am touched, but I really I want to thank and remember all the people who preceded me in this fantastic adventure of the wind tunnel that will continue in the future for the next 50 years. Thank you very much.
Thank you very much, Mr. Pininfarina. Now I would like to invite to the stage the Chief Executive Officer of Pininfarina, Silvio Angori.
Thanks, and welcome from my side as well. And it is really a touching moment, this one, to be here and with all of you show the wind tunnel beyond the curtain, as you will be seeing in a moment. And as it has been said by our chairman, Mr. Pininfarina, this is a laboratory. And everything that you see here has a reason of being, okay? So everything, these, the walls, the ceiling, everything that you see here is instrumental to test the flow and the acoustics of cars. And not only cars, because in reality this lab is used to test buildings and airplanes. Everything that you can think of that has to be, let's say, confronted with the wind and has to move or has to stand the wind is then tested in here. And this is really what has been done by the foresight of Mr. Sergio Pininfarina, and with the link with the Polytechnic here of Torino, Politecnico di Torino, that has really imagined something that after 50 years is still up to date. We've been renovating this lab in the last few weeks just because it needed, right, some repainting. But in reality, the core of this lab, it is the one that has been conceived 50 years ago, that has been kept and maintained over the years, and is today still at the leading edge of the aerodynamic research. And what is really important is that we have done some other improvements to this lab that is projecting into the future, right? During the visit, you will be hearing much more about it, so I will not be anticipating anything more than what has been said already, but keep that in mind. This is a lab, a living lab, that in addition to what is today, is meant to be an asset for those that are involved in design and in aerodynamics and aeroacoustics. And because of that, we are opening up relationships with universities, not only here in Italy, but even in Europe and in the US, opening up let's say, the asset that has been developed, the competencies and knowledge that have been developed over so many years to the industry, and not only the industry, but for those that will be wanting to develop competencies in aerodynamics. And with that said, I think that it becomes, it has been said by the chairman before, the importance of this tool to develop new vehicles. Yes, it was opened at the time of the crisis, of the oil crisis in 1973. But today, if we think about the electric vehicles and the importance that aeroacoustics is regaining again, and the importance of aerodynamics, that I think makes this wealth of competencies crucial for the industry, and not just for Pininfarina, but for the whole industry. This is why we're looking at opening up ourselves to the outside world. Finally, I wish to remind you all that this building is an historical building. And so every time that we touch anything, we have to go really through several approvals that make us proud, because it means that we are using an asset that is deeply rooted into the history of this part of our country that we are very proud of being part of. Now then, in a few moments, you will be listening at some very interesting conversations, and then later you will be guided through a tour of this lab that very proudly we are opening up to you all. And with that said, let's enjoy this celebration. Thank you.
Thank you, Mr. Angordi. On this very special day, we are pleased to have as our guest Mr. Emanuele Gaito, the new mayor of Grugliasco, the city which hosts the wind tunnel. We would be honoured, Mr. Gaito, if you wanted to say a few words.
Good morning, ladies and gentlemen, and it's an honor for me to welcome you on behalf of the city of Grugliasco, and we have a partnership with the Pininfarina company for many years, and we're proud to have the Wine Gallery, an example of Italian excellence in our area. Grugliasco is a city that is very active in attracting investment in this area. Between 2023 and 2026, we will have approximately 350 million euros of public and private investments. The main investments is the expansion of the university with the City of Science and Environment, which will bring great innovation. Within this project, we are also the butterfly area that we create spin-offs of about 115 companies The city of Grugliasco stands out for its industrial history in the automotive sector. We want to maintain this specialization and connect with the major investments we will experience in these years. In this way, we will connect the excellence we have the area of with innovation. The Pininfarina company is an classic example for innovation and excellence. I hope that our fruitful collaboration can continue for a long time to come. It's an honor for us to have the Wind Gallery in our territory. Thank you on behalf of the City of Grugliasco.
Thank you, Mr. Gaito. As we said earlier, the decision to build the wind tunnel was unconventional in 1972. It prefigured a technical and industrial scenario which still appeared a long, long way away. But the future arrived earlier than was expected. In 1973, the First World Fuel Crisis placed demands on the motor vehicle manufacturers to consider every opportunity to minimize fuel consumption. Design for reduced aerodynamic drag became a high priority and led to a significant increase in the demand for wind tunnel testing time and new wind tunnels. Automotive aerodynamicists working over the last 50 years will tell you that drag coefficients have typically halved in this time, and that the art of the experimental aerodynamicist is to use measurements of shape changes made in the wind tunnel to guide the optimization of their vehicles. The most significant advances are made in the early styling phase, working with designers and modelers, and often sculpting full-size clay models in the wind tunnel. Today, the aerodynamics contribution extends to ride and handling, reducing wind noise, providing cooling airflows for powertrains, brakes, and electrical components, and in minimizing the effects of inclement weather. Similar aerodynamic design and test techniques are used in motor racing, in sports engineering, and in the design of marine craft, because the fundamental physics are the same, and aerodynamic efficiency can make a significant difference to success. Perhaps just as highly influenced by aesthetics as road cars, but less obviously perceived in terms of aerodynamic performance, is the design of buildings. Their shape and form is just as important with regard to wind loading in relation to strength, durability, thermal characteristics, and also on their effect on surrounding buildings and the local environment. And now we would like to introduce some friends who have come to visit us and can testify to the value that aerodynamic and aeroacoustic studies can have in all areas. Together, we would like to explore how the two key drivers for the history of Pininfarina, aerodynamics and sustainability, go hand in hand, not only in the automobile, but also in all verticals in which Pininfarina is fully committed. So let me introduce our guests who are already seated on the stage. I'll move into this other position. Okay. So from my left, going around, I introduce you to Mr. Roberto Camusi, full professor of fluid dynamics at the University Roma Tre. Paolo Fuggenzi, sponsorship manager of Basic Italia. Marcello Percuso, president of Percuso Marine. Kevin Rice, chief creative officer Pininfarina, and Professor Matteo Sonta-Ricorda, vice rector for research at Politecnico di Torino. And remotely connected from China, hopefully we have Daniele Terriboldi, vice president of vehicle engineering for NEO, and Maximilian Ganes, associate director, energy management team of NEO. So first of all, I'd like to ask Mr. Camusi, as professor of fluid dynamics at the University of Roma Tre, you came to Pininfarina for a 2-week aeroacoustic test campaign with the Aerocal model. Can you tell us what the aim of the Aerocal project was?
Yes, thank you for the introduction. And so we start with aircraft rather than cars. So actually, the project was dealing with aircraft noise. It was funded under the Horizon 2020 European framework, and it was one of the projects that was under the topic of developing, let's say, quieter and greener aircraft. And the idea is to use electric engines rather than conventional combustion engines that are, of course, less impacting from the pollutant viewpoint. But the problem with the electric engines is that the power that they provide is much lower than conventional combustion engines. So if you want to produce enough power, you have to use many propellers driven by electric engines if you want to drive, let's say, regional aircraft. And so this is the concept of distributed electric propulsion, that is aircraft equipped with, let's say, 8, 10 propellers driven by electric engines. And this concept is actually feasible from the technical viewpoint and very useful from the aerodynamic viewpoint in terms of aerodynamic performances. But the main drawback is noise. You know that one propeller is very noisy, 2 propellers are very noisy, 10 propellers are really too noisy. Both in terms of community noise, and so the noise towards the environment close to the airports, but also in terms of interior noise, so there is a big problem with comfort for passengers. And so the idea of this project was to perform a parametric analysis of scale model. You can see the picture is a model equipped with 2 propellers driven by electric engines. And the attempt was to try to identify which is the configuration less noisy, that is less impacting from the aeroacoustic viewpoint.
Okay, so can you tell us a little bit more about the type of test results you actually achieved here, and also what you think the impact that they have on sustainability into aeronautics?
Yes, actually, this wind tunnel is, even though is not a fully anechoic wind tunnel, is very suited for this type of tests and is very well equipped in terms of, let's say, instrumentation. So we got a lot of data. We are still in the process of analyzing this huge amount of data, but actually we were able to identify the parameters that are more affecting the noise. So the idea is to identify which configuration is in terms of position of propellers and the phase between the propellers that is less impacting in terms of noise emission. Of course, these results are the basis for industries, for companies to develop this kind of technologies. But I have to say that the path towards a quiet aircraft in this sense is still very long. And to this extent, I can let's say, announce that we are in the process of having another collaboration with Pininfarina in the next year to test even more complex configuration. Is a wing with 3 propellers installed. So we will test here, and we will have this challenging task of making very intensive parametric studies. We will have 3 weeks of tests here, and it will be a pleasure for us to come back here and have the interaction with this very, really high qualified also and smart technical staff that is driving this facility.
Thank you. Thank you, Professor. Can we see?
You're welcome.
Mr. Fagenza. Okay, so your company BasicNet turned to Pininfarina, the wind tunnel, to measure drag generated by your technical fabrics, I understand, for sports equipment. What prompted you to ask the fabric for high performance?
First of all, thank you all to have the opportunity to stay with you and to attend this event. In this case, we are speaking about Kappa brand, that is the brand with which we commercialize on the market sportswear. From the moment that we are a sponsor of the Italian Federation of Ski since 2011, we decide to work with the wind tunnel of Pininfarina for 2 reasons mainly. One, because the federation asked to us to develop something technical and something performing for their athletes. The second reason is the way we approach sponsorship. I mean that when we work with a national team, a football team, a rugby team, we try to develop something new, not only for a stylish point of view, but also for technical point of view. This is because it's very important for the athletes, also because it's very important for us try to do something different from our competitor. Of course, Adidas, Nike, Puma are bigger than us, and so we have to create our little space on the market, trying to do something new from a technical point of view. For this reason, are more or less 10 years that we work with the wind tunnel of Pininfarina, because we understand that to create a performing track suite for the skier, we need the support or something, support of laboratory like this. And so we decided to test not only fabrics, but also race suite on the wind tunnel.
Okay, thank you. And can you just say how important aerodynamics is on a fabric and what impact it can actually have on an athlete's performance?
We are speaking about speed in sports, and in particular on the ski sports. Sometimes just 200ths of seconds could win a gold medal on the Olympics. For this reason, we constantly have sharing information about the federation, about the wind tunnel, just to try to developing something important, something performing for the athletes.
Thank you. Thank you. And now I hope we can talk to Mr. Ganis, who's remotely connected from China. Okay, so if you can hear me, Mr. Ganis, okay. So NEO designs and develops smart electric vehicles. How important is aerodynamic and aeroacoustic research in the development of such vehicles? And how much is it different with respect to the classic combustion engines car development?
Sure, okay. I think optimal aerodynamics and low air resistance play a much bigger role for electric cars compared to internal combustion engines, traditional vehicles. Fundamentally, in an EV, the amount of energy available is quite limited. It's limited by the capacity of the battery. So it's crucial that the overall energy efficiency of the vehicle as a system is generally taken into consideration when someone is designing and building a new range of electric vehicles. So for electric vehicle OEMs, battery range is an important factor, specifically that it's constraining the popularization of new energy vehicles when current power exchange facilities still have not had a wide range or expansion or distribution. There's still this range worry amongst many users of electric vehicles. So it's very important that energy efficiency and the conservation of the available energy is maximized, so as to increase the obvious parameter that when a user will be buying the vehicle, which is range. Generally, in electric vehicles, about 50% of the total energy consumption goes to the aerodynamics. So it's quite clear for us that reducing the air drag resistance is of fundamental significance for reducing the overall energy consumption and therefore improve the performance of the car, but not just the performance, such as the range. It also affects the maximum acceleration, the vehicle speed, the driving performance, and therefore overall, for NEO, we are interested in increasing the user's expectations of how we would use the car beyond the way he would normally use an internal combustion engine car. At the same time, the absence of the combustion engine also increases the user's perception to other things such as the aeroacoustics. So the overall wind noise of the car is greatly focused towards the interior of the cabin, and so aerodynamics and the role of the aerodynamics towards the wind noise plays a much higher role. One aspect that we haven't touched on, that we are also using aerodynamics specifically to improve the overall use of electric vehicles is also the presence of a higher range, let's say a much higher presence of sensors for autonomous driving vehicles, to which electric vehicles are, let's say, headed. So using and understanding better the aerodynamics with this focus is now a lot more important. So currently in NEO, aerodynamics development in particular is a key aspect that allows us to optimize the vehicle's drag and lift forces, obviously, to achieve world-class driving performance, but also support the aeroacoustic development to provide excellence in cabin ambient experience, but at the same time sustain the development of vehicle contamination and water management to enable a premium level of endurance under all environments. To give you an idea, just for me to conclude, aerodynamics development, or focusing on the aerodynamics in terms of understanding the energy efficiency of the car is much easier than optimizing other parameters such as mass, for example. A typical development cycle for aerodynamics generally tends to reduce the drag of a car for about, let's say, 60 counts, which translates to about 40 kilometers improvement in range. In order to achieve the same performance from reducing the mass of the car, for example, you would need to reduce the mass by about 300 kilograms, which is incredibly difficult. Just to give you a context of where we are today.
Okay, thank you, Mr. Gannis. Okay, now hopefully we can talk to Mr. Teobaldi. Okay, the concerns regarding global energy supply have prompted the world to rethink mobility again. And there's been talk of reopening coal mines. What's the vision of a company that focuses entirely on electric propulsion?
Hi, good morning, everyone. I hope you can hear me well. First of all, thank you for this opportunity to Pininfarina team. Actually, we are very thankful to Pininfarina because maybe you don't know, but NEO is quite new. It's a new company. We were born early 2015, and in late 2015, we were already testing in the Pininfarina Wind Tunnel, and the team there were really squeezing hours out of because typically wind tunnel are always fully booked night and day. So we appreciate that we were really well treated from you, and you started this aerodynamic culture in NEO, and then Max obviously is a very well representative of it. The question about energy, of course, energy is a very wide topic. There's many dimensions, geopolitical, of course. We have the strategic dimension, we have the economical dimension. As we know that, Max, maybe you need to move. Yes, and so yeah, there are many dimensions. I would like to focus on the environmental dimension of energy. Now OEMs, they don't have at least NEO don't have a lot of do a lot with certain decisions, right? We all know that the current moments are not ideal, but we also know that the tension, the trend, the commitments to have a cleaner planet is irreversible. There are many activities and decisions taken, like the Paris Agreement or the pledges to have net zero emission in the fleet taken by each countries. The UNO with the Sustainable Development Goals and so on. Those are all pillars for this trend, which is irreversible. And NEO, as an electric vehicle maker, of course, is very much engaged with all of this. When it comes to environment, typically an automotive product, a car is judged by the footprint, the elements normally for the carbon footprints, the manufacturing cycle or vehicle cycle, as it normally called, utilization cycle, and then there are other programs that the OEM can entertain to offset, let's say, this carbon footprint. For the manufacturing cycle, we are, of course, starting from the basics. We have 2 production sites. all of them on the roof as solar farms. That's pretty basic, okay? We are also engaging in activity like the clean material, so the green aluminum, for example. So it is a commitment that the aluminum, automotive grade aluminum that we are using is actually coming from renewable energy in the transformation starting from the raw material. There are other activity as well related to recycling. Of course, electric vehicle batteries are a huge topic again when it comes to recyclability and reutilization as well. In the utilization cycle, so when the car is driven, Max already explained how strategic, how important is the aerodynamic, the low drag coefficient to reduce consumption. On top of that, the driving style of the user is also very important. The NEO is pushing for a more environmentally friendly driving style with the blue points. So basically our users can get these points proportionally to the less energy consumption that they can score on the car, basically. And finally, as I said, we have also offsets program. The one that you saw in the video is the Clean Park. Recently is an agreement with the WWF in which basically we are giving our cars to the parks as light duty vehicles so that the park personnel can use them inside these environmentally control areas for their daily operation. I think it's a nice way to be also, you know, paying back to the environment what is in any case consumed and the carbon that we emit. Obviously, right now we are operative in China, what is our primary market, but by end of the year we are planning to enter the European market, and also these activities will be available in Europe as well. So I think, as I said, energy, of course, huge topic. NEO is taking this environmental responsibility very seriously in all the phases that we can make a difference. So.
Mr. Tiabaldi, thank you very much indeed.
You're welcome.
Okay. So now I turn to Mr. Pasecco. Okay, the relationship between Pasecco and Marine and Pininfarina has generated a couple of sustainable boats in which aerodynamics has been crucial, the Pasecco F70 and the Fly 40. Can you tell us a few words on these two projects, please?
Yes, thank you very much for the introduction. Well, the Fly 40 was a project that started from almost a dream I had when I had the opportunity to be on board of Luna Rossa, America's Cup team. Actually flying at 50 knots was clearly a new experience for any sailor. First time you feel the G-force, because in sailing you never feel the G-force when you tack or jibe, when you are maneuvering. So I thought, why can we not develop a circuit, and the boat of course, that allow private owner to race in with not investing 100 million euro budget, which is the budget for participating to an America's Cup campaign, but with a significant, we are talking about like 2-3 million euro budget, which again, out there are many owners that are interested to race in this circuit. So we work together with Pininfarina and a few former engineers from Luna Rossa to develop this Fly 40 boat that has to combine the aerodynamics together with the aesthetics and design features, considering as an owner-driven boat. So it was a challenge. I have a feeling that, it's a personal feeling, that when you work on aesthetic but driven by aerodynamics, the work should be easier. But maybe Pininfarina has a different opinion, but that's my personal opinion. Aerodynamics helps to make things looking nice. And we developed this amazing machine. Consider that, I mean, those boats obviously has no engine, so the aerodynamics is everything to get the speed. And then we develop together also, I mean, thanks to the good experience and relationship, we work together also on the Persico 70, which is an offshore racing machine, which means you go out really doing record-breaking across Atlantics or long race. So we had to work again on aerodynamics because it is a full foiling boat, so again flying boat. But we had to work carefully also on the interior because again, when you do long range race, you sleep on board, and a private owner which afford that kind of budget, he want also a kind of minimum comfort on board. So that's where the project we work together with Pininfarina.
And the continuous research for perfect aerodynamics has led you, as you say, to the creation of the boat that flies on water. Can you explain how the result was achieved and the advantages in terms of, let's say, sustainability and performance?
Yeah, again, aerodynamics in any racing environment are the key. And we start working the America's Cup back in the 90s with the Moro di Venezia, where we machine, for the first time, we did machine the keel and the bulb with a CNC machine, which was at the time kind of innovative. We are a group that come from the automotive business, which is our core business. So for us was kind of normal, but not for in the marine environment. And again, this was a feature that clearly was essential in terms of performance and the hydrodynamics. Now we are talking about boats that are flying, so you are not only caring about the part of the boat that is in the water, that are now the wings, which obviously are the most important part to achieve the performance, but now we have to consider also everything above deck, which times ago in the 90s, I mean, you look from an engineering standpoint, structural standpoint, but not at all from an aerodynamic standpoint when you go at 10 knots. Now, going at 50 knots, we had to spend a lot of energy, and we find out only the last Cup in New Zealand, the improvement on the fairing, on the fairness of the deck was giving the edge to really make the difference. And again, when you are racing and you are competing of seconds, a detail in the fairness of the deck, we found out make big difference. In terms of sustainability, of course, this process, I'm talking about the foiling elements in the boats, are bringing, I think, a big, let's say, push into the sustainability path for the powerboat. Because on powerboat, if you have a foiling powerboat, then you don't need to push the water anymore, or let's say you push, but for a small amount of surface. So then the efficiency of the boat increases significantly. That means that the electrical engine become really practical, because you don't need tons of batteries to have enough range, given the efficiency that come along with the foiling boat.
Okay, thank you very much. Thank you.
Thank you.
Okay, so now I'm going to turn to Mr. Rice. Okay, being Chief Creative Officer of Pininfarina is a great responsibility, because this company has always not limited itself to designing beautiful shapes, but is strongly committed to aerodynamics and green mobility. How can design and aerodynamics contribute to making means of transport more sustainable?
Pininfarina, I think, is unique in the sense that it's never been a styling organization from when it was first created 92 years ago. The whole idea was to bring together the engineering side of things, the innovation side of things, and the design side, and that's how Pininfarina was created from day one. That's still our DNA today, and that makes us unique. That allows us to come up with solutions which the past has shown have created really timeless vehicles. But when it comes to sustainability, and in particular today, I think the basic equation, designers are not very good at maths, but we can do basic equation, and I think the most simple equation of all is how much energy is needed to push a vehicle through the air. And in terms of being as sustainable as possible, you want to have the minimum amount of energy pushing your vehicle through the air. So looking at where engineering is going, we're all moving towards electric vehicles. Electric vehicles to get range and performance, unfortunately mean vehicles become heavier than they were 20, 30 years ago. So for that reason, design and aerodynamics is so much more important now than it was even 20 years ago, because to offset that weight increase, then it's really, really important to make sure that the way the vehicle breaks through the air is done in the most efficient way. And recently with the Teorema concept car, the virtual concept car we showed last year, working together with the slimmest of platforms in terms of height was really important, because it does two things. With a flat floor, it gives you a chance to break into new packaging areas, which allows you then to free up areas. In the case of the Teorema, it allows us to free up areas where we can use the passage of air through a vehicle, not just around it, to dramatically affect the efficiency of the way the vehicle breaks through the air. So this was a completely new approach for car design, in a sense, because only because you've got the flat floor do you have the packaging freedom to do that. And then at the same time, the more efficient the vehicle is, then that offsets the necessity to increase the weight because of the batteries, or the other way around. The more efficient the vehicle is, the less heavy the batteries have to be. So if, in its most basic terms, sustainability for the future is about spending minimum energy, then Pininfarina has always worked hand in hand with engineering and innovation teams, and will continue to do so.
Okay. So with green technologies, how much freedom do designers actually have to study shapes? And how do green technologies change the impact that aerodynamics has on style?
So what's a green technology? That's one of those great big words, and we all sort of like have our own ideas of what green technology is. But if we just put it into basic terms, at the moment the world's going electric. Fast behind the electric world is the hydrogen world. And you probably know most of you that recently working on a project using hydrogen power. And that was an interesting development, because it's not just about where the hydrogen tank is, but it was the understanding of the partner company we were working with that in the very near future, we're not looking to have lots of charging stations, hydrogen charging stations across the planet. So to avoid having issues of how to refuel the vehicle, we worked together with them with an idea of interchangeable capsules, which are much easier to distribute across a travel network. And that brings a completely different approach to the vehicles, in this case, the rear end of the vehicle, completely new shapes, completely new proportions. And another thing we've done very, very recently is working on hypercars. And hypercars, as you know, it's very important, not just how the air goes in, but how it comes out, especially of the wheel areas. And generally speaking, that means designs have to be split. There have to be air exits along our nice, beautiful, elegant surfaces. Well, we spent a long time recently looking at alternative ways to make the air exit and make that invisible. So that's one particular vehicle which I've got in mind, which in the near future, maybe you'll see that soon. And there you won't see where the air exits in one particular area of the vehicle. But that meant, together with our innovation team, our engineering team, we had to look at it in a completely different way, and it made the vehicle so much more pure looking, so much more simple looking. And that again goes into the idea we want to keep things timeless, elegant, and innovative.
Thank you. Very interesting. Okay, Professor Sonza, we imagine that aerodynamics and sustainability are at the heart of studies in the Politecnico di Torino. What do you think are the future trends in these fields?
Okay, so good morning to everyone. Let me first say that I'm really happy to be here because this is a trademark of our meeting, I guess. I mean, here you really feel how much experience, how much skill there are in our area. Coming to the question, sustainability is a key word today. Everyone uses it, is happy to use it. I would say that Politecnico invested in this area since many years. When the current rector in 2018 came to his position, appointed a vice rector for sustainability. And this, let's say, guided the whole university in this direction. Just to give you an idea of how successful this has been, there is a ranking for green campuses, and this year we were, let's say, ranked 22nd at the world level in this ranking, meaning that well, our efforts in different directions, but concerning sustainability was quite successful. Obviously, this covers different areas from research to teaching, even to, let's say, external relationships. And let's say, I think it's a matter of providing an integrated flavor of activities to our students and to our partners. Clearly, let's say, in terms of sustainability, the link with mobility and the link with aerodynamics is very strong. It is traditionally very strong, but I think that it is a link which has to be completely renewed because things are changing. Well, you know that we played as a Politecnico quite an important role in the creation of this infrastructure. We also have a smaller infrastructure inside the university, and we use it for different purposes connected to teaching, but also connected to research activities, especially for validating, let's say, the analysis, the aerodynamics analysis coming from computational fluid dynamics and computers. And we try to combine these activities in different directions. Originally, automotive was the main activity, then aircraft came. At the moment, a lot of activities are done even in new fields, for example, validating and study the performance of wind turbines, analyzing the robustness and resilience of civil infrastructures when, let's say, exposed to stresses, winds, etc., for example, antennas, etc. Obviously, other mobility, let's say, areas are also of importance. Trains, well, we are not so strong in boats yet. I hope we will be able to improve. I'd like to mention that in terms of sustainability, the recent, let's say, investments of our government in terms of PNRR, let's say, funds, allowed us to play a key role in the new center at the national level for sustainable mobility, where we play a key role, and I think that activities in this area will be included in this, let's say, initiative.
Yeah, that's key. Okay, so the ongoing cooperation between Pininfarina and the academic world has continued with tests in the Pininfarina Wind Tunnel on the project developed by the students of the H2 Polito team. An example is the vehicle EXAM, which I think is extreme automotive mobility, a low-consumption city vehicle prototype, wholly designed and engineered and developed by the students. So thanks to this research, the EXAM has won prestigious prizes. Can you tell us more about this project, and have there been any further steps?
Yes, this is, let's say, an initiative we are quite proud of, because since many years now, we supported and, let's say, stimulated the creation of these student teams. This is one of the most prestigious and successful, the H2 Polito team. And this team is composed of students and created several successful vehicles. XAM was not the first one, but one of the most successful. It was a hybrid vehicle, and this one, and it was, and the aerodynamics was verified using the Pininfarina Wind Tunnel. This vehicle won quite a lot of international awards, both for the performances but also for the design. So it was quite important for us. I think it is important because it allows our students to challenge themselves on real problems, not only technical problems, but also on interacting with external bodies like Pininfarina, for organizing this kind of experiments, for promoting their work, for selling their work, for fundraising, which is also important. And this is a good experience. This project was then continued with XAM2, which is equipped with an electric engine powered with a fuel cell, hydrogen fuel cell. And let me also remind the latest vehicle, which is Hydra. And Hydra appeared a few moments ago on the screen, is a very aerodynamic vehicle, which also won recently an award in Pays de la Loire competition due to his, let's say, shape, combining, let's say, performances and, let's say, attractiveness and beauty. Let's say.
Thank you. Thank you, Professor Sonza. Well, gentlemen, thank you very much for your sharing so eloquently some insights into your work, and particularly for many industrial and research projects, the details of aerodynamic development often remains highly confidential. And now I'd like to hand over to Alessandro Aquili, head of the Pininfarina Wind Tunnel.
Good morning, everybody. First of all, I'd like to thank our guests for this exciting tour around the world of aerodynamics in all its forms. And now we are reached the most spectacular moment. With the cameras, we will enter the test area and find out how a test on a car takes place. And what a car! Our sister company, Automobili Pininfarina, gave us the opportunity to test the amazing electric hypercar named after our founder, De Battista. Let's start the tour from the outside. You can easily recognize the iconic shape of our wind tunnel. This is now part of our logo. When we bring the car into the tunnel, we position it in the center of the test section, over the rolling road. We always prepare the car in the test section before the entrance, for reducing setup time. Now the whole team can start its work. The wind tunnel staff have different skills. We have mechanics, electricians, software developers, and aerodynamicists. In this way, we are able to manage the different aspects of running this facility, from testing activities to maintenance and development. The first operation we do after the vehicle enters the test section is to lift it up using the forks under the wheels. Operators then can connect the car to the struts that exit from the floor. These struts have multiple purposes. They keep the car in position, connect the car to the underfloor balance, allowing so the measurement of the forces that the wind generates on the car, and then can be used also to adjust the car ride height during the test. When this operation is completed, we can lower the car to a nominal ride height. The following operation is the final alignment. This is a very crucial operation. Obviously, for having good test results, the car must be perfectly aligned with the wind. For this activity, an operator stays inside the test section and he verifies the position of the car using a laser tool aligned with the center line of the tunnel. The fan adjustments in position are made by another operator from the control room. This is an iterative process that they can repeat for the front and the rear of the car until the perfect alignment is achieved. You can see that they are checking the rear. With alignment completed, we are almost ready to start the measurement campaign. If we are going to perform any aeroacoustic test, we will position 3 microphone arrays that are used to define the position of the noise sources at different frequencies with a technique that is called beamforming. Now the test can begin. The operator is ready to push the start button for activating the fan and the rolling rod. Our wind tunnel can run up to a speed of 250 km/h with wind and rolling road as well. As soon as the tunnel reaches the test speed required by the customer, the operator can start the data acquisition. We can perform many different types of measurements. Most often required are the measurements of the aerodynamic forces, but we can also measure flow regimes around the vehicle using an automated traverse rig, and as mentioned before, we can measure aerodynamic noise as well. A unique instrument in the Pininfarina Wind Tunnel is our turbulence generator system. It's a very impressive tool which is comprised of 5 pairs of flapping wings. The wings are 3 meters high and when required are raised from their home under the floor. The system allows us to generate controlled turbulence that simulates some condition that the car can face running on the road. Very often our clients wish to visualize the flow around their car using smoke. This is a very useful technique that helps provide a more intuitive idea about the aerodynamic characteristics, but is also spectacular and probably is what many people imagine when wind tunnel testing is mentioned. As soon as the test is completed, our engineers analyze the results to check if everything is in order before providing the data to the customer's engineer. This was a very short example of what the testing in the Pininfarina Wind Tunnel might include. I hope you enjoy it. Thanks a lot for your attention.
Sorry, can I? That's all in Italian for me. Sorry. My Italian's not quite that good, I'm sorry. So, yeah, could Mr. Aquili say these words? Yeah, so look. Sorry. Thank you. You rescued.
Vorremmo sul palco Mr. Stefano Serra, vicepresidente delle Unioni Industriali e presidente AMA.
Ma questa non era prevista, però è un piacere. Paolo, Silvio. Sì. Paolo, Silvio, è bellissimo il frutto del grande coraggio che 50 anni fa qualcuno ha avuto guardando alla tecnologia. E ancora oggi non solo è vivo, ma si è rinnovato. Quello che abbiamo visto è come queste tecnologie che nascevano per un'idea di velocità, il vento, la macchina, in maniera antesignana, oggi si applicano in tanti campi. Io porto i saluti sicuramente di Giorgio Marsiai, presidente dell'Unione Industriali, e vado più in là anche di Federico Visentin, presidente di Federmeccanica, che mi ha voluto in squadra. È una gioia essere qua oggi, perché sinceramente io non avevo la percezione, finché non ho visto e ho ascoltato il panel di chi ha relazionato, di quante cose si possono fare con un wind tunnel. Quello che abbiamo oggi è celebrare un bellissimo compleanno, ci prepariamo al prossimo, quindi giustamente come diceva Paolo. Dall'altro lato credo che questo sia un altro degli elementi che certificano un fatto, che questo territorio ha un grande coraggio, un genius loci che nasce da persone così che si animano nel quotidiano e lavorano seriamente, da 50 anni, lo faranno per altri 50, sono attorniati da tantissime imprese che si muovono nella stessa misura e questo è quello che caratterizza e rende diverso questo territorio. Un territorio che ha saputo integrare manodopera proveniente da varie parti ed è una capacità umana che non si trova da tutte le parti, che ha saputo far emergere le eccellenze. Oggi abbiamo parlato in inglese. Sorry, I'm addressing the public in Italian. I hope the English part will not be very disappointed. E questa è una grande festa che ci deve rendere contenti perché certifica una capacità che abbiamo. E non è guardare al passato, è guardare all'oggi e al domani. Quello che Silvio, Paolo e tutta la loro squadra costruiscono nel giorno per giorno insieme a tante altre imprese. E quindi grazie per oggi, felice di festeggiare un compleanno e soffiare le candeline con voi e lavorare per le prossime.
Now I invite on the stage Mr. Marco Gay, Presidente di Confindustria Piemonte. Thank you.
Beh, grazie e buongiorno anche da parte mia. Ringrazio Paolo, ringrazio Silvio, ringrazio la Pininfarina in realtà per avermi concesso oggi di essere qui a festeggiare un evento importante e un'azienda e una competenza, una capacità che non solo ci rende riconosciuti e riconoscibili come regione, come industria nel mondo, ma che rende anche onore al lavoro fatto tutti i giorni, da chi guarda il futuro ma ne costruisce oggettivamente dei pezzi importanti. Quindi complimenti. Ringrazio moltissimo i relatori perché ci hanno dato la possibilità di vedere a tutto tondo, mi verrebbe dire a 360 gradi, come aver investito 50 anni fa in qualcosa che non c'era oggi rappresenta non solo una leva industriale, ma rappresenta uno sguardo verso realmente i prossimi 50, 100 anni, quindi verso il futuro. E per me quindi veramente un orgoglio poter rappresentare come Confindustria Piemonte tutte le industrie che rendono orgogliosi di quello che sappiamo fare, ci aiutano a raccontare una capacità, una competenza e una volontà che, permettetemi un po' di campanilismo, è tipica dell'essere un imprenditore torinese, essere un imprenditore piemontese che sa quando investire, che lo fa nonostante e che quando vede i risultati, permettetemi, non solo dice è un successo di tutti, ma dice ho fatto la mia parte per un pezzettino di futuro. Quindi complimenti e grazie di essere stato invitato qui oggi.
Okay, mi scusi, my Italian needs to improve. Thank you, Alessandro, as well for your contribution just now. Ladies and gentlemen, as we draw the formal part of this event to a close, I thank you on behalf of Pininfarina for joining us in person and online on this special day in Grugliasco. It's always important to celebrate anniversaries so that we can take the opportunity to look back and be inspired by those, including Professor Morelli, Ingegneri Cogotti and their colleagues, who had the foresight and courage to invest their time, expertise and talent in designing and continuously developing this facility. That today's celebration of the 50th anniversary of the Pininfarina Wind Tunnel is entitled La Forma dell'Aria, the shape of air, is entirely appropriate, or as my friends here would say, perfetto. Okay, Alessandro? So now you take over. Yes, sorry? Yeah? Okay. So do you want that? Sorry, do you want that as well? Sorry. Yeah,
There was a misunderstanding, sorry. Now, for those that are physically present, you will have the chance to visit by groups of 20 people at a time the testing area that we just saw in the video. Here you will see the schedule of the visits. Make a note of